welcome students to Brainstorm. So basically we are going to complete the third part, which was the left part from part 1 and part 2 of real numbers. So this part has to be very small because not much was left. So the first question is express root 2 as irrational. So we know that root 2 is irrational, but we still have to express root 2 as irrational. So let us assume to the contrary that root 2 is rational. So if we express root 2 as a rational number, therefore we know that root 2 has to be equal to a upon b. Once I get a upon b, after we get a upon b, now we can rearrange this term and we get b root 2 is equal to a. So we get this. Now if we square on both sides, we get 2b square is equal to a square. So this is because we squared on both sides. When we square this, the root goes out. When we square this, we get b square. When we square this, we get a square here. So now this proves that 2 is a factor of a. So the next step that comes is that we have to express it as a as 2c. C is any integer. So when c is any integer, you can take any value. And now we get a is equal to 2c. So when we substitute this value for a, we get 2b square is equal to 4c square, which when we simplify, we cut here, we get b square is equal to 2c square. So this proves that 2 is a factor of b, but this contradicts our fact that a and b are co-primes. Co-primes are numbers which come back after back, which are prime numbers. So these are co-primes, but that means they only have factor 1 and their own respective numbers. But we also get 2 here, which means this is wrong. 2 is not right. So why did this happen? Now the last statement we have to write is this contradiction has arisen due to our incorrect assumption of that root 2 is rational. So basically, if we write root 2 is irrational because our assumption was wrong, because we know that root 2 has to be irrational. So the last statement will be root 2 is irrational because our assumption was wrong. So this is this first question done. Yeah. So now let's come back to the second question. Express root 5 as irrational. So basically what we did with root 2 there has to be done with root 5 here. So we first can write that root 5 is assumed to be rational. Once we assume it to be rational, henceforth we can write root 5 is equal to a upon b. And this a upon b, in this we know that a and b are co-primes. That means that they only have a 1 as a factor and are back-to-back prime numbers. So since this is a very important fact, because you have to use this again, so keep an eye on this. The next part will be rearranging this formula so that we get root 5b is equal to a. Now we'll square both sides. Square both sides. So after squaring both the sides, we will get 5b is equal to a. So this assumption proves that 5 is a factor of a. Now we have to prove 5 as a factor of b also. So to prove 5 as a factor of b, you must write A is equal to phi c for any integer c. So A is equal to phi c. Now when we substitute the value of A in the formula, we get phi b square is equal to 25 c square. So we can divide the phi and 25. We get b square is equal to phi c square. So this proves that phi is also a factor of b. But since we wrote a and b are co-primes, this should not be possible. Hence our assumption is wrong, and we must write that root phi is irrational since we wrongly took an assumption. So this is the last line you have to write, and this question is done. Yeah. So the next question is, show that phi minus root 3 is irrational. So we have to prove that phi minus root 3 is irrational. So let us assume that phi minus root 3 is rational, just like we assumed in the before parts. So we can express this now as phi minus root 3 is equal to a upon b. Upon rearranging, we get root 3 is equal to phi minus a upon b, which can also be written as 5b minus a upon b. So after we write this, hence since a and b are integers, we get phi minus a upon b as rational. And so if this is rational, henceforth root 3 has to be rational. But this also contradicts the fact that root 3 was irrational. But this contradicts the fact that root 3 is irrational. So once we get this irrational, so hence since root 3 is irrational, then phi minus root 3 also has to be irrational. Therefore we can write phi minus root 3 is irrational due to. So this was the second last question, and the next question is the last one. So the last question is, show that root 3 root 2 is irrational, which is 3 root 2 is irrational. So this is the question. We have to prove that 3 root 2 is 3 root 2 is irrational. We have to prove this. So now let us assume that 3 root 2 is rational. So if we assume 3 root 2 is irrational, we can express 3 root 2 in the form of a upon b. And when we rearrange this, we will get root 2 is equal to a upon 3b. Once we get this, root 2 is equal to a upon 3b, Since a, 3 and b are integers, they are rational number. And since this is equal, then they both have to be rational numbers. Therefore, root 2 has to be rational. Therefore, root 2 is rational. But this contradicts the fact root 3, root 2 is irrational. Henceforth, proved root 3 root 2 is irrational. So that's all for this chapter. We have completed this chapter and see all my dear students soon with the new latest chapter. Till then, goodbye. And don't forget to ring the